Hey guys, happy Thursday. Hope the homework went well on Tuesday and yesterday. As a reminder, that was due to me this morning, so you should have already posted photos of your work and your answers. And if you have not looked yet at the key that I posted, please make sure you stop this video, go look at those. Just so you can kind of like have a frame of reference for how you've done, because I'm not going to be able to go over all of the questions. Just kind of pinpointing some ones that from the answers I've already seen, I can tell that people have struggled with, or just anticipating that you all might need some extra help with. So the first set of questions, 1 through 6, these are on the fundamental counting principle. Again, that's when you're just figuring out how many possible options or how many possible decisions you have based on how many decisions you have to make, like how many sub decisions within that decision, and then how many options you have for that decision. So like a classic example, number 2, you're picking an outfit. You're told that Kendall has 7 shirts, 3 pairs of pants, and 2 jackets. So when you were picking out an outfit, right, you have to think about how many like sub decisions you're making. 1, 2, 3. You have shirt, you have pants, you have jackets, right? And then you are asking yourself, well, how many options do I have for each of those decisions? So I have 7 options for shirts, 3 for pants, 2 for jackets. So all you have to do to figure out how many total outfit options you have is just multiply those numbers and you get 42. So that's an example in which you have 3 different decisions. Each decision has like a different number of options for it. Number 4 is a good example that looks a little bit differently. Grant is rolling a standard 6-sided number die 8 times. Oh, you guys can see what I'm watching on YouTube. All right. How many outcomes are possible? So he is rolling a die that has 6 sides 8 different times. So if you want to visualize it, that would be 1, 2, 3, 4, 5, 6, 7, 8. That would be 8 different outcomes, like 8 different things that happen. And each time, how many options does he have? Well, it tells you it's a standard die with 6 sides. So each of the 8 rolls has 6 options. All right, so that would be 6 to the power of 8, which is 1,679,616. So those are like the 2 major types of fundamental counting principle questions that you would be asked. One, like question 2, where, every decision has like a different number of options. And then a question like number 4 or like number 5, number 5 says a quiz has 8 multiple choice questions. Each question has 4 options. So that would be, like you have 8 things that are happening, blah, continue that 8 times, and each one has 4. That would be like 4 to the power of 8, right? So the ones that like are exponential like that are a little bit different than 2, but like it's all within the same vein. Let's actually take a look at question 6, just because this one is a little bit different. When Jack bought his new truck, there were 96 different ways his truck could be equipped. He had 4 choices of engines and 2 choices of transmissions. If the only other available choice was color, how many colors were available? So here it tells you your final answer. It tells you that there are 96 total options, right? He could choose, from 96 different specific designs of this car. So that's usually what we're looking for in a final answer, but it tells you that. But it's asking you for one of the subset of decisions. It's one of the choices. So it says, the decisions he has to make is engines, and it tells you that he has 4 to choose from. Transmissions, and he has 2. And then colors, but we don't know how many colors there are. But we do know that in total, there's 96 different options. So this is just, solving for x, right? 4 times 2 times x equals 96. So you're just dividing 96 by 4 times 2, or 8, and you are getting 12. So it can work in reverse as well. All right. The bottom part of this page is just factorial, or rather questions 7 through 10 is just factorials. I'm not really going to go over this a ton because I think it's pretty straightforward. If you are having any issue finding the factorial button on your calculator, you need to let me know, but I'm not going to go over these right now because the answer key has been posted. Questions 11 through 14 are just standard permutation combination questions. If you have not looked yet for those functions on your calculator, please look for them. I did have several people reach out asking for help finding them. If you are still not sure, where they are in your calculator, I hope to see you in office hours so we can go over it together, or you can FaceTime me or send me a picture of your calculator and I'll help you. But for these, it's really straightforward, right? Like you just plug that into your calculator and you get the answers. If you don't have that function on your calculator, if you looked it up and you know that you don't, then you just have to use the formula. But again, 11 through 14, I'm not going to do because those, you have the key for and they're really straightforward. 15 though says find 9p9 and 9c9. Why are the answers different? Well, 9p9, I'm just going to say the permutation of it is 362,800, and the combination is 1. And I explained this on the lecture on Tuesday, but the difference between a permutation and a combination is is it specific? Yes, permutation, no, combination. So an example of 9p9 would be there are 9 players on a baseball team and the coach is trying to make a batting lineup. So all of the 9 players are going to bat. We just don't know what order they're going to bat in yet. So that would be 362,800 different options that the coach could make for that lineup. Versus 9c9 is there are 9 players on a baseball team. The coach needs to pick 9 to bat. It has nothing to do with order. He's just choosing 9 players to bat. Well, there's only one option there, right? It would look very different. And if I said there are 20 people who tried out for the baseball team and the coach could only pick 9, right? But anytime you're saying, well, there's 9 people to start with and I'm choosing 9, there's only one option for that. So that is why those answers are different. It's because in combination, the order does not matter. All right. So the next page is the same type of setup as that classwork page that I did. So you are identifying whether it's a permutation or combination and then finding the answer. So again, if you can use your calculator for that, I strongly recommend doing it. If not, just use the formula. Let's do quite a few of these because I anticipate this is where, the majority of you are going to struggle. So number 16, Scott has 17 chores to complete this Saturday. How many ways can he arrange the order in which he does them? Arrange. We made a list of keywords, right? Arrangement is one that tells you it's a permutation. Anytime things are arranged, they're specific, right? So it's a permutation where n is 7, right? He has 7 chores to complete. And how many ways can he arrange the order in which he does them? That implies he's doing all of them, right? He's not just picking 4 chores. It's not like, his parents said, here are a list of 7 chores, pick 4 of them and, make a schedule for yourself. So that would just be a 7p7. And if you are doing that as a formula, you want to make sure you are using the formula we learned the other day, which is the factorial of n divided by the factorial of n minus r. So that would be the factorial of 7 divided by the factorial of 7 minus 7. We know that 7 minus 7 is 0. And we know that the factorial of 0 is 1. So that refers to the shortcut that we had. When n and r are the same thing, you just have, you know, the factorial of n. Again, I strongly recommend taking the time and finding those buttons on your calculator because it will save you significant time. Okay, number 17. Looking at a different thing on my computer than on here. There are 16 different colored markers in the bucket. How many ways can Kelly choose 5 of them? All right, so choose, that signifies combination, right? There's no specific order that's involved here. So N is 16, R is 5. So 16C5. All right, I'm going to do this one with the formula just so you see one formula for P, one formula for C, but then from now on I'm not going to do the formulas. So that would be factorial of n divided by the factorial of r times the factorial of n minus r. Okay, so the factorial of 16 divided by the factorial of 5 times the factorial of 16 minus 5. I'm running a little bit out of space here. Okay. So factorial of 16 divided by the factorial of 5 times the factorial of 11. Final answer, 4,368. I realized I didn't give you the final answer for number 7, or no, not number 7, number 16, which is 5,040, even though I already posted the answer key. There you go. All right. Number 18, how many ways are there to elect a president, vice president, treasury, secretary, and treasurer from a club with 32 members? So this one doesn't have any of our indicators in it, like 16 had arrange, 17 had choose. Elect, let's go ahead and add that to our list. All right? Because when you are, actually, back up. I did not say that. No. Okay. This says elect a president, vice president, secretary, treasurer. Those are specific roles. So as I explained on Tuesday, right, if you were elected to a specific role and then they just say generally like, oh, you are in the administrative board for this club, well, that's not the same thing, right, as being elected to be the president or the vice president. So this is a permutation. However, it could say, how many different ways can you elect 5 people to be on the administrative board from a club with 32 members. So the word elect in itself does not signify either way. So you really just have to make sure you understand that roles signify specificity. All right, so it's a permutation. The total number that you have to choose from is 32 because that's how many people are in the club. But then the number of roles that you're assigning is just 1, 2, 3, 4. So this is a 32 P4. I'm not going to do the answers here because you can just reference them. 19, the dance company is choosing 3 dancers from a group of 25 who try out. How many different ways can they choose the dancers? So choose signifies combination, right? You're not ranking them. You're not putting them in specific roles in the Nutcracker, right? So combination, N is 25, R is 3. There are 10 toppings available to make an ice cream sundae. How many ways can Max choose 2? Choose, right? And always think about the situation. Don't just look for the word and say, okay, I got it. Like, think about it, okay? When you're putting toppings on an ice cream sundae, like, you're not preferencing them in terms of like, well, this is the topping that's going to go on first because it is my most favorite topping and it needs to be closer to the ice cream. Like, no, right? You're just putting the toppings on the ice cream. So combination, he has 10 to choose from and he is choosing 2. How many different 11 letter arrangements can be made using the word firecracker? So anytime we have a question like this, we have to see if it's a repeater or not. So, does F repeat? No. Does I repeat? It does not. Does R? It happens 3 times. E happens twice. C happens twice. A doesn't repeat. K doesn't repeat. We already took care of the rest. Okay, so the way that we do these problems, right, we know it's a permutation because we're talking about arrangements. But this type of question is different than our, permutations that aren't with repetition. Like, you can't just plug it into your calculator. You have to use your formula here. And the way that we do that is our numerator is just the total number of total letters we have, like 11, right? 11 letter arrangement. And then the denominator is the number of things that repeat. How many times do they repeat? So R repeats 3 times. So that's 1 triple repetition. E repeats twice. So that's 1 double repetition. C repeats twice. That's 1 double repetition. So when you do all of that, you get 1,663,200. So that one is our little anomaly there. All right, Mindy is purchasing a song from an album on iTunes. If the album has 14 songs, how many ways can she choose? 6, choose, combination. It would be different if she was making a specific playlist in which, like, the orders of the song mattered, like she was, like, but that's not what's happening. Okay, so it is 14C6. Carl is choosing 4-character password for his cell phone. The password can contain letters and digits only and can't contain repeating characters. How many passwords are possible? So this is really fun. So let's sit with this one for a second. First, let's answer, is it a permutation or a combination? So it doesn't say anything about it being like an arrangement or a lineup. It also doesn't, it doesn't really, like, for me when I read this, it wasn't super clear to me. It does say choosing a 4-letter password, but I want you to think more critically about this, okay? In a password, let's say you have like a PIN for your phone and there's 4 digits in the PIN. Well, do the order of the digits matter when you're entering them? Yes, right? That's how passwords and PINs work. The order matters, it's specific, and that's what makes it a permutation. We know that it's going to have 4 characters. So we know that R is going to be 4, but the big question is, what is N? All right, how many does he have to choose from? So it says, okay, the password can contain letters and digits. So how many letters are there? There's 26 letters. How many digits are there? There are 10 digits. All right, so 0 through 9, those are your digits. So together, there are 36 options for him. All right, so it is 36 P4. All right. Number 24, Mr. Pratt has 26 students in his class. He has 3 prizes to give away, a pencil, an eraser, and a no homework coupon. How many ways can he choose 3 students to win these awards? So this is another one that you really need to pay attention to, because if the prizes weren't specified, if it just said he had 3 prizes to give away, then it wouldn't really matter to you. Like if the prizes were all the same, or they were just like some vague thing that you didn't like know what it was, right? Then it wouldn't matter to you which one you won. But these 3 things are different, right? A pencil, an eraser, and a no homework coupon are very different things. And if you win the no homework coupon, I'm guessing you're not going to be happy if you're just randomly given the eraser. So it's specific. It's a permutation. N is 26. That's how many total students he has to choose from. And he is choosing 3. Number 25, how many ways are there to choose 7 cards from a deck of 52? Choose, right? But we're not only looking at the indicator, we're thinking about it, right? You are not putting the cards in any specific order, an arrangement, a lineup. So it is a combination 52C7. All right. So that is it for me today. If you have any additional questions, please make sure you are reaching out. I hope that this was comprehensive enough for you. Make sure you are completing the allocated time on iExcel, and I will